Yes, can you hear me? Is that
Please turn on your camera. Sir. Yeah.
can you hear me? Basically, is that okay? Is that
Ah,
clear?
you. Shall we start, sir?
Yes, sure. Is that should I start now?
Do a formal introduction.
All right. Let me share my screen. Good afternoon, everyone. I hope you can clear.
Before starting the session, I used to introduce you.
All right, sure. All right. Okay. Thank you.
Once again, I welcome you all for the second session of a day two on the topic optimal scheduling of blocking vehicles. It's my privilege to welcome our esteemed resource person for the second session, Dr. Ahmad Asrul Ibrahim, to deliver the lecture on the interesting topic that is optimal scheduling of EVs, blocking vehicles. As the blocking vehicles such as electric cars, bikes aims to balance the energy demand, minimize the charging cost, and ensure the grid stability. And the efficient scheduling strategies helps to improve the integration of renewable energy sources, reduce the peak loads, and enhance the battery life. Before entering into the lecture, I am happy to introduce the eminent educator, Dr. Ahmad Asrul Ibrahim, who is currently working as senior lecturer in the Department of Electrical, Electronic and System Engineering, University, Kebangsaan, Malaysia. He received the BE degree from University Kebangsaan, Bangi, Malaysia in the year 2008. And after that, he has completed MSc degree from University Kebangsaan, Malaysia in the year 2012 and PhD degree from Durham University, Durham, UK in the year 2018. His research area of interest are distribution system automation, electric vehicle integration, artificial intelligence, renewable energy integrations, power quality assessment, and demand side management and smart system. We are privileged to have you with this today's session, sir, and we look forward to gaining a valuable insights from your expertise. I invite Dr. Ahmad Asrul Ibrahim to take over the session on the topic optimal scheduling of blocking vehicles. Sir, please.
Right. Thank you very much to the organizer for inviting me to this very interesting session. All right. Let me share my screen. I think. Screen. Can you see the screen or?
Yes, sir.
All right. Okay. All right. So yes, has been introduced that my name is Ahmad Asrul Ibrahim. Okay. I'm from University Kebangsaan Malaysia. Basically, in English, it's National University of Malaysia, right? So basically, today I'm going to deliver this topic: optimal scheduling of plug-in hybrid electric vehicle. Slightly different from the time schedule, right? It's missing the term hybrid here. I tell you why I choose hybrid in this case. Okay. So we will look into a power grid ancillary services perspective. All right. So, all right. Okay, this is basically to introduce to you where I'm come from. So this UKM or Universiti Kebangsaan Malaysia main campus is located in between Putrajaya and our capital Kuala Lumpur. Okay. So as you can see, it's from this diagram. Maybe I can use pointer. Okay. So it's about 35 minutes from international airport. Okay, Sepang. Okay, as you can see, it's a really big campus. It's about 2,700 acres. Okay, size of the campus is quite big campus. And where's my the faculty is basically here. Okay, near to the forest, we have permanent forest in the campus. Okay, so basically our main sustainable development is one of the goal from the university. We rank at 138 worldwide QS ranking and 28 in the Asia ranking, right? In the time higher education, basically 400 to 500 university worldwide, and in Asia is basically 101. Okay. All right, that's basically background from the university. Okay, let's go to the main topic today. I believe why we talk about sustainable development, mainly because of this concern, our concern on the global greenhouse gas emission, right, keep increasing every year. As you can see, the major contributor of the global greenhouse gas emissions come from the electricity generation and also transportation. Is quite big contribution. So this is where the main contribution to produce electricity. And the second one is basically transportation. So if we can contribute or to migrate from the conventional ICE internal combustion engine car into electric vehicle, so basically we can reduce this gas emission. That's basically our main target, right? So we expect that more electric vehicle in the market near future, right? At the same time, we look into more renewable energy instead of we depend on the conventional generation. So maybe we look for alternative using the renewable energy like solar power, wind power, and so on. Okay. Right. So what the issue with the renewable integration? This some from many issues or challenges about renewable energy integration. So basically, this issue will be addressed in this basically in this presentation. Okay. All right. Is it okay over there? All right. Let me continue. Okay. So basically, we know that if we depend on renewable energy. So it's basically intermittent nature of the output. Okay. As you can see, you cannot control. Basically, you cannot control the output of the generation. It depends on the weather condition, right? For example, solar is peak during the midday, and at night time you don't have resources. Okay. And for the example, wind really depend on the weather condition. Okay. And we have demand or load consumption, consumer that consume the energy. Basically, you cannot control people to use where to use it, right? So it's really now it's become mismatch between the demand and the generation. So with this issue, then how we can have a high production from renewable energy? So that's limited the integration of renewable energy. The second one, if you look at this capacity, normally we do the power system study, power system analysis on the network before we allow people to integrate their resources. For example, solar. If you want to install solar, then we do power system analysis and look whether this amount of capacity that you want to install we can absorb. Otherwise, we stop at certain limit, right? So because of this capacity, is limit number of integration of renewable energy. Okay. Then the third one is imbalance. For example, you cannot control. Basically, I don't know in India, but in Malaysia, definitely we open at certain area, okay, with incentive to install solar energy on top of your house, okay. But basically, you cannot tell people who to install, who don't, right? So basically, you leave it to consumer to participate in the program or the incentive provided by government. So you have the issue where a consumer at certain area interested to join, the other area don't interested to join. Okay, then as you can see, it's basically imbalance between the feeder. So basically, one feeder with heavy loaded with renewable energy, the other one don't have much integration of renewable energy. For those feeder with high generation, then you have issue with voltage rises, okay, and somehow can be violate the limit, right? For example, in distribution is around plus minus 10%, right? In general, but in Malaysia we practice plus 6% minus 4%, so it's slightly different from the conventional. Okay, so the thing is this we have tap changer to control the voltage in the main entrance. If you reduce the voltage, you step down the voltage, then this second feeder violate the lower boundary. Okay, if you increase, then you violate the upper boundary. So that's the issue. So we cannot. That's the main issue of renewable energy. Okay. Then now we look how PHEV can help to cater this problem or issue. Okay. All right. Back to this PHEV plug-in hybrid electric vehicle. Why I choose this instead of, we have different type of electric vehicle. We have battery electric vehicle. We have hybrid electric vehicle, right? So we have plug-in hybrid. Why? I suggest you to focus more on the plug-in. The number one is that if you want to migrate from the conventional to the zero emission vehicle, you cannot change drastically. Okay, you cannot just move everything, just go to the full EV. Definitely you cannot do it because yeah, of course, the infrastructure and so on. So we cannot do that. The second one is basically this PHEV have their own fuel tank. Okay, for example, if you want to contribute to the power grid, then you have lower what we call the energy store in the battery. So basically, you can use the fuel tank as a backup to generate the electricity. So basically, we have a generator inside to charge the battery. So basically, the main source come from the battery pack. And if you have low energy in the battery pack, so basically you can generate. So we have generator inside, okay, to charge the battery so that you can consume more energy from the battery. Okay, so in this case, if you connect to the grid, this PHEV can be a mini generator, right? So you imagine that you have a small generator inside the network. So basically, you can contribute to the power grid. So how you can contribute? Basically, we have this plugin. So that's why we have P there, plugin. So you can connect to the power grid and contribute to the power grid. So the main idea of this, basically, you can provide electric mobility. So you don't no longer depend on the infrastructure. So this vehicle can move around. Then you can transfer the electricity to the other feeder, to the other location. Okay, maybe I move to the next slide. Right, this is how PHEV can contribute in power grid. As you can see from the diagram, it's move around, right? From the transportation sector, maybe go somewhere to the what we call playground area where you have a solar generation there, right? And you go back to your residential area in your house. Okay, so basically you move around. So when you move around, if you connect to to that section, so basically you can provide ancillary service. What are the ancillary service? Basically, you can reduce voltage right just now because we have higher voltage higher voltage, so you can reduce the voltage a bit, okay, by contribute or consuming the electricity from the power grid. Okay, then you can reduce infrastructure. For example, if you have some development area, normally what we do, we do the power system analysis and upgrade the infrastructure. It's very costly, okay, compared to you utilize the PHEV. So why I say that? Because the worst case scenario, the highest consumption maybe occur in 3 or 4 hours a day. Not really for long, maybe in some season or something. So you are this situation really depend on the season. Okay, so if we invest infrastructure, so basically the money just go there and you only utilize for in per year maybe 20 or 40 hours only per year. So to avoid that, so we can utilize the PHEV. In this case, as you can see, the electricity can be transport. It's no longer depend on the infrastructure. Can transport from the feeder, this feeder to another feeder through the electric vehicle. Okay. All right. So definitely you need to have a power grid control center to manage the thing. Without a proper management, let's say you just leave it, no control, just leave to people to do the operation, definitely become chaos, and you have maybe really the issue is not addressed. For example, the voltage rise just now is not addressed, and you have more issue. For example, more imbalance of the feeders because you don't control. So therefore, you need to control it. So we call it scheduling of PHEV operation. That's why the title is optimal scheduling. Okay. So okay, I think that's about the topic that we want to discuss. Okay. So before we go further, just I would like to explain a bit on the enabling technology. How we can enable it. Just now, I think from the previous speaker already talked about this V2G, IoT, and so on. Okay, this is really the basic one that you need to enable the optimal scheduling of the PHEV. Number one is flexible tariff and incentive. Without this, without incentive, definitely people won't involve. Okay, so people involve basically based on incentive. You pay something, then people start to involve. You don't pay, then definitely no benefit to that person. Definitely people won't contribute. Okay, and this is the main thing: vehicle to grid. Yeah, definitely if you want to contribute to the grid, you require this technology, vehicle to grid. So you contribute to grid. And IoT, definitely IoT. Why is IoT? To get more information, come to the fingertip of the user, so that user can go to the location where you target, where you plan to when you plan to charge or discharge. Okay, right. So IoT basically tools to get information. Maybe I go one by one. Vehicle to grid. Maybe you familiar with this? Maybe previous speaker already talked about this. Maybe I just recap. All right. So we have electric vehicle. Currently we have this charger station. Charging station mainly mono-directional, so it's maybe one way from the grid to the vehicle. So now we can improve a bit on the charging station. We convert it into bi-directional inverter. Okay, basically the flow can be from the grid or from the vehicle. Okay, so you have control unit to allow it to discharge. In this case, you as an owner can sell energy to the power grid. Okay, so we use the bi-directional charger. Without the bi-directional charger, definitely this couldn't happen. Okay, so you need to allow to sell the electricity to the power grid. Okay, this is the technology. So how to enable it is you require some incentive. Okay, flexible tariff or some. Currently, I don't know in India, but in Malaysia we have a flat tariff. Okay, fixed tariff. But if you go to certain country, they have this flexible tariff, depend on your subscription. If you subscribe for flexible tariff, then you have fluctuation in your bill. It depend on the time of use. Okay. If you refer to this, you can see that it's lower. Some area you have low price, and this peak price here. Okay. For if you are the user, you can charge during this time at a lower price, and you can sell back in the peak time. Okay, so you gain some money from there. Okay, we did some study on that. We found that if you do this regularly, on the daily basis, basically you can cover the cost to replace the battery. Okay, cost to replace the battery is quite high, but if this maintain the process every day, if you have this kind of pattern, so basically you can cover the cost replacement of the battery. Okay, so in this case, it will encourage PHEV to contribute. On top of that, this depend on the tariff. Basically, no contribution from the utility company. So utility company can also contribute by add some incentive to encourage more people. Okay, if you want to encourage people, basically you can reduce further the price. Okay, so in this cost come from the utility company. Okay, if you want to make it more people come to discharge, then you increase more here. So give some extra money. Okay, so that will encourage people to get involved. Why I put this diagram here? In Malaysia, what happens is that if you park, for example, you have apps that you charge your electric vehicle in the parking lot. You have the parking lot for the EV, right? So you park there, and somehow you have this session, for example, 4-hour session, right? And you come to this session, and suddenly you get notification mention that, oh, your car already full charge. Okay, what you can do, what you should do, basically, you need to go there and move your car from the car park, the EV car park. Otherwise, you get penalty. You can see this 2 ringgit there, penalty, if you don't move your car park, your car in the car park, EV car park. So therefore, why we impose that, we try to avoid misuse of the charging area, so that the other car can charge their car. Okay, so we call it penalty idle. We call it idle penalty. So you don't do any charging operation, therefore we charge you because of that. Okay, so basically no free parking. But for other incentive, for in this case, if you contribute the power grid, maybe we can introduce free parking, because the owner is not operating in idle operation. You can discharge to the grid when needed. Okay, the active process operation still there, so there's no term like idle operation. So in this case, you can allow in from the owner side, the PHEV owner side, we look this as a incentive, right? I can park there without worrying about a penalty, and we get extra money from there. Okay, because of the process you buy and sell during the parking session. Okay, so in this case, we'll encourage more people to charge their car, right? You may interrupt anytime during the presentation. It's okay. I'm okay with that, so that we have more fruitful discussion, right? It's not one-way discussion. Maybe we can not wait to the end, toward the end, to the Q&A session, but along the way, you can interrupt me. Okay, it is okay, no problem. Right. Okay, next, basically IoT that I mentioned about information. Okay, mobile apps. So this is really important to get information. So this peninsula of Malaysia. Okay, as you can see, lots of charging station there available. Okay, so now we want to identify where the location to charge. So basically, this IoT mobile app can identify the best location for charging, for discharging. Okay, all the information come to your to mobile, to your phone. Okay, so you can go there to the location that, for example, in UK, we have petrol station with different prices. Okay, so if you want to get kind of benefit from there, from the cheap price, you can look on the apps. You go to the cheapest one, so you can save money from there. Okay, by filling your car with a cheap price. So this information is really important, so that you can you can get people involved in the program. Without information, people don't know, and people don't try to involve. Okay, maybe further features, maybe we can introduce energy price bidding. Normally bidding come from the big company, the power provider, big power provider. But nowadays we talk about in the consumer level, we have EV, small size of EV, distributed size of generation. So not only that kind of people can contribute in to provide you the energy price, maybe the consumer can bid and involve in the energy price bidding, so that you can fix your price. So then you willing to contribute to the grid. Okay, so with all the information you have, so basically you can get involved and get benefit from that. Okay, so information, we have all this technology nowadays, so I think in near future we can use this PHEV as what we call the energy transfer agent. Instead of depending on the transmission power line, you can use PHEV to transfer the energy. Okay, all right. So let's go more into technical a bit. So even though it's not too technical, we make it kind of simple example to show how this PHEV can contribute to the power grid and how we can benefit from that. Okay, so we can model it as a load during charging, okay, and generator during discharging, because discharging you produce energy, you inject energy to the power grid, it's act like generator. During charging, basically you consume the energy from power grid, then you can model it as a motor. Okay. So from network perspective, because when we do analysis, we look at a power network perspective because we want to see the benefit to the power grid. That's why I mentioned in the first slide mentioned about power grid perspective. Okay, so from the power grid perspective, during discharging, we have some internal losses. Okay, because you need to convert from the battery storage, you want to convert into the power discharge. So basically, there's some internal losses. Yeah, conversion of energy, definitely you have losses there. All right. So let's say eta there. Okay, efficiency. We call it efficiency. Okay, discharging is efficiency. So if you consume 10 kilowatt from the battery, basically deliver is less than that. Basically, you can get less than that 9 or something, or 8 kilowatt. Less than is it consumed from the storage. Okay, but during charging, okay, during discharging, it's not involved. So if you consume 10, basically from the grid perspective, you consume 10 kilowatt, but you receive less in the storage. Storage is not our interest. Our interest more on the network perspective. So therefore, you can neglect the what we call the internal losses. Okay, so because we look at this point of view. So if you consume 10, you receive less. But if you consume 10 here, basically it's 10 is fixed at 10. Okay, therefore you don't have this eta in the discharging process. Right. Right. Furthermore, on the state of charge, SOC can be neglected. To simplify the model, okay, you can neglect. Why is you can neglect the SOC? Because the car that charge at the same place won't come again. Maybe the other car will come and contribute. So you don't know what the what we call the state of charge of the next car. So you don't have that information unless plugged to the station. Then you get the information. Otherwise, you don't get the information. So this SOC state of charge doesn't bound to the other car. So because we have different car, different vehicle, right? So it's not bound to the SOC. So you don't have to calculate the state of charge. We can assume that those cars that want to contribute basically have enough energy. For example, if you want to discharge, basically that car at high level of state of charge. Otherwise, you won't discharge. Okay, if you have low state of charge, definitely you don't discharge. Otherwise, you cannot move after that. Okay, after discharging process. Okay, so similarly, if you have full charge, definitely you're not charging anymore because it's already full. So basically, those have a room, empty room in the state of charge will charging. Otherwise, you won't. Okay. So because number of car in one substation, we talk about power grid. Let's say we talk about medium voltage. Okay, it's not one station. We have plenty number of station. Okay, so connected to the particular substation. So this number of station can be variable that you can control. So basically, you want to know how much power that contribute there at that particular point. Okay, so we have this number of connected PHAV. Okay, and maximum is given by the available connection point. If you have 10 charger, definitely you cannot go more than 10. So it's limit at that particular number of charger that available in that place. Okay. To make it simple, we assume all the buses have the same number of connection point. Otherwise, you can put the setting different number, But to make it simple, you can assume all the same number of same available charger point, okay, charging point or connection point, okay. And at one location, we can assume single mode. Why single mode? Basically, if you want to bawa incentive to charging, definitely people won't discharging. If you encourage people to discharging, people won't charge. Won't charging. Yeah. If you want to encourage discharging, for example, discharging, people don't charging. Okay. So therefore, at that particular place, we can put a single mode of operation, either charging or discharging. It cannot. Definitely, it can involve two operation, but the thing is, we talk about incentive. We want to know where location to charge, of where to discharge. So therefore, no point to have this two mode of operation. Otherwise, it cancel each other. Then you get basically no point of having these two condition. You can just ignore it. Okay. So maybe you have more charging point, but these two location, one is charging and discharging, they will cancel each other. Basically, you can, from the network perspective, is basically zero. It's nothing there. Okay, so basically we reduce the available connection point. So to do the scheduling, you need to know the maximum what we call effect of the process. Okay. All right. Let's we move further. Okay. All right. In this slide, I will talk about in the result we talk about heuristic optimization technique. Okay. We have why we suggest this optimization technique because of optimal scheduling is non-convex and non-linear problem. Why I say non-convex? Because if you want to decide number of car can be 1, 2, 3. It's integer, right? So when it's integer, it's jumping from one number to another number. It's not floating number. It's no point. There's no 1.5 car charging in one place. Definitely no, because either one car or two car. This jumping is make it non-convex. It's jumping. The number is jumping, right? And nonlinear, you know that in power flow calculation, using sine cosine operation, therefore make it non-linear. Yeah, definitely you can use numerical method like interpoint method and other numerical method. But the thing is, it may trap in local minimal. So you may get certain solution, but it's not really the lowest or the optimum solution. Okay, the global optimal, right? Okay, so we have so we suggest that to use heuristic optimization technique. Okay, so we have plenty of technique of heuristic optimization technique. We have the first one is gravitational search algorithm. So basically, is the ideas come from attraction between the two the planets, interaction between planets in the process of moving around, you get the solution. And the second one is Grey-Wolf optimization, GWO. This basically the inspired by the hunting mechanism of Grey-Wolf. Okay, how they try to find the food and catch the food. Okay, wind-driven optimization, how the this wind um, um, carry the air pollens, for example, seeds like this throughout the space, okay, and find the best place to to grow the what we call this tree. Okay, and the other one is jellyfish search optimizer, GSO, is based on the jellyfish searching for food and migrate, something like that. Okay, so based on this techniques of optimization technique, we do comparison. We do we check with the best optimization technique that's suitable for the optimal scheduling of PHAV. Okay, we use the heuristic optimization technique. All right. Okay, case study. Basically, we can do many case study. So, but in this case, we just focus on worst case scenario. If you cover the worst case scenario, basically you cover the whole situation, and you can see the worst condition. This is the worst condition. How you can benefit in the worst condition, right? So therefore, I consider this two worst case scenario. The number one is high generation, where all the renewable resources operate at maximum. Okay, at maximum, at low demand. Okay, so demand at 40%, the lowest demand. So this create kind of worst case scenario during the high generation, high integration of renewable energy, high what we call injection from the renewable energy. Okay, and then we try to see how this PHEV can contribute to reduce or balance this thing. Okay, the number two is high demand, no generation. For example, you use solar at night time, you have high demand that all the demand, all the consumer consume the energy at no generation. This the second worst case scenario. These two worst case scenario basically cover the 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 whole scenario. Okay, the whole. So if you have in between case, yes. Okay, so I carry on. If you have scenario where in between, definitely the impact will be less. Okay, so this is the worst case. This is the worst impact to the power grid. Okay, so we use this system, modified attributed bus system. So one is modified the original system without renewable energy. We put renewable energy inside. So it's basically from the previous publication in the R3PE transaction. Okay, use this kind of test network. Okay, you have high generation of renewable energy, or you can say distributed generation. Okay, so we have 6 altogether. Okay, so and you have so in this case, I assume that each location that we try to identify 2 locations for charging and 2 locations for discharging. So one location have 20 charging point. Okay, 20 charging point. We limit this. It's up to you. You can change the setting and you can see the different result. Okay, and we consider Honda Accord model. This Honda Accord basically will give this rating 6.7 kilowatt. During charging is 6.7 kilowatt. We assume that during this charging also 6.7 kilowatt. Okay, right, and efficiency at 80%. Okay, so we got all the information. Now then we can apply in the framework that I mentioned before in the modeling system, and to see how this contribute to the power grid. Okay, first of all, we compare the different optimization technique. We run for 30 runs or trial, you can say trial, 30 trials, and see which technique. We have 4 techniques just now, right? GSA, GWO, WDO, and GSO. So we try to find the best optimization technique, and yeah, that's basically you can use that technique to solve the problem. Okay, from this comparison, case 1, you can see that GSO give the best in terms of fitness or reducing the power losses. Okay, in all category, worst, average, or best, because we run 30 runs. Okay, so we compare and see which is the best. So basically, GSO give the best in all together. So but the thing is, it takes some time to converge. Okay, some time to converge. In terms of convergence, GSA the fastest convergence. As you can see, average is 5 iteration already get solution. Convergence important if you really need a fast solution. But can you bear with this inaccurate solution? So it's kind of trade-off. GSA in terms of fitness is the worst one. Okay, you can see the worst also the highest, right? The best also this. GSA among the worst. Let's say we exclude this GSA and we compare in terms of these three, GWO, WDO, and GSO. You can see that in average, GSO is the fastest one, okay, among the three, okay. So give you accurate solution, somehow it quite fast compared to the other two, not including the GSA. Okay, we look at case number 2, high demand and no generation. In terms of fitness, similar pattern. We can see that the best is GWO, and for conversion also same pattern. Okay, and you can see that if you compare the three, so you can see that GWA in average is comparable to the GWO. So why go for GWO so that you can if you can get better or accurate solution. So in this case, I would suggest to use Jellyfish Search Optimizer, okay, GSO, to solve this optimal scheduling problem. Okay, so among the 4 technique, we can choose one, okay, and do further process. Okay, this is in terms of convergence. The blue color one, GSO. Okay, how we select this convergence? Basically, we select among the best solution. Okay, and then we take the convergence pattern characteristic of this. For case, we apply for case 1 and case 2. As you can see, GSA really quick convergence, go down and converge. Yeah, in I think 1 iteration already converge. Okay, but the thing is, it's not good solution. If you look GWO, quite fast. At the end, somehow in here, GSO take over the place. Okay, become the first, the lowest value. But the thing is, for this case, if you can see the best solution, all 3 give you the same solution. But you can see from this characteristic, the conversion between these 3, JWO basically the better than GSO in terms of convergence. And you can see the second condition where among the 3, the slowest convergence basically go to GSO. Okay, so in this case, but anyway, if you look in terms of computational time, I think they're almost the same. Okay, almost the same computational time. Okay, right. Okay, now we look into the benefit to the power grid. In these two case scenario just now, high generation at low demand. So basically, I put symbol in this to show that we have generation, we have some output from the from the renewable energy. Okay. In this figure, you cannot see this symbol because no generation. So basically, no injection from the renewable energy. The red color of vehicle basically indicate charging operation. Blue color represent discharging. Actually, we allocate in each case study 2 location for charging and 2 location for discharging. But the thing is, the solution provide for discharging basically 0 vehicle. That suggested 0 vehicle somewhere around here, if I'm mistaken. But the thing is, 0 do not basically contribute anything, just 0. So therefore, I don't put in this figure. Okay, so 2 location for discharging basically 0, 0. So that's why I don't put it in this figure. So we have only charging operation, and you can see that it's charged kind of at the bottom of the feeder, right? So why is charging at the bottom of the feeder? Basically, you can reduce the energy traveling from here. If you have surplus of energy, definitely will be absorbed by this external grid, right? So if you have PHEV in between, then PHEV will consume. So because it's consume the energy and become less transferred to the power grid. So from this arrangement, basically this is optimized. You schedule the PHEV to charge basically as at bus 17 and 18. So basically you can reduce about 12.7% power losses. Okay, the original without PHEV, the losses is about 432.6 kilowatt. But after contribution of this PHEV, you can see that reduced to 300 something, 377.8 kilowatt. Okay, so a kind of reduction, quite significant, 12.7%. Okay, if you look at case number 2, case number 2, high demand at no generation. You don't have the generation. Definitely, the system is high loaded. Okay, heavy loaded with the load consumer. Okay, consume the energy. Okay, what happens is that blue color indicates that this vehicle is discharging. Okay, discharging, contribute to the grid so that you can reduce the power. Why is here? Basically, you can reduce power depend on the external grid to supply and traveling along the longest feeder here. So therefore, you can reduce the power losses. Okay, because you reduce the amount of power traveling from the external grid. Okay, in this case, you can reduce about 14.8% from 202.7 into 172.7 kilowatt. Okay, as you can see, maybe this place 18 similar place. If you compare these two conditions, in this case 1 charging, in this case 2 discharging, right? But if you refer to the second location 17 and 32, right? So you can see that this car can be traveled from this location to that location to transfer the energy instead of through the what we call to the infrastructure power line. You can transfer through the vehicle from point 17 to point 32, bus number 32. Okay, so from there you can see that power is basically you could transfer there from during the high generation, at the no generation, then you can transfer the energy there. Okay, you charge at 17 during the high generation, and you at the no generation, then you discharging at 32. Then you can jump without having this infrastructure. You create the transmission line from here to here to connect, so you don't have to invest on that. But still, you can transfer using the electric vehicle. Okay, we look at the line loading. Okay, line loading. I mentioned 3 issues just now: imbalance between feeder, maximum capacity, hosting capacity, and water right issue, right? Okay, but let's look at the line loading. The power rating for line number 1 until 5, basically 5 megawatt. Other than that, others are basically 2 megawatt. Okay, it's different rating basically from this point to the right and to the left is different point. What we call rating. Okay, let's examine the first case study. You can see a very drastic drop here. Okay, before and after. Before, that's mean you don't optimize, no contribution from PHEV. And after, that's mean you optimize or you do the scheduling, optimal scheduling. You can see the reduction. You can see some areas 120 because of because the original power line is not considering high generation of renewable energy. That's why it's violate here. Basically, the original power grid, you don't have the renewable energy, therefore you don't have this issue, violation of the loading. Okay, but when you consider high generation, so sorry. All right. So basically, in this case, normally we do the curtailment, the power energy curtailment from the renewable energy. So now, if you involve the PHEV, so you don't have to do the power curtailment from the renewable resources. Is it okay over there? Okay. Sorry, I don't see the MS team because I opened the slide. I cannot see. Is it? All right. I think I proceed now. Is it okay? I proceed. Okay. So you can see a drastic drop there. Okay. Basically, you no longer depend on you reduce the injection from the renewable energy. You absorb through the PHEV, so you can reduce the loading. Okay. Right. So if you compare the maximum, you can see the reduction. But at certain area like this, you have increment loading. Why you have increment? Because you charging in this area. Okay, you charging in this area 17, line 7, bus number 17 and 18 just now, right? So we charge there. So it consume more energy, they increase the loading at that particular line. But still, if you compare to the original one, still not really high increment there. Okay. Let's assume this case, the second case. You can see this normal condition. Before this normal condition, the original power, the power grid. So you can see less than 100. Right. This is the original one because without the generation. Okay, but even the original system, if you introduce PHEV, so you can see the reduction at the main feeder. Okay, assuming that you have 5 megawatt transformer at the figure at the main feeder, you can reduce almost half of the loading of the transformer. So yeah, that can reduce lots of loading to the to the transformer. Okay, and you can see this at certain point is increased, definitely because of charging from the PHEV. Sorry, not charging, discharging, because you don't have generation. Then PHEV start to inject power to the grid, and you have high loading here because contribute to that point and deliver to the neighbor. So you can see the deduction after that. So therefore you have high loading there because of injection. Similar to this, as you can see, after you can reduce the loading. This bus number 32 just now, okay, and bus number 32 is heavy loaded at that feeder. You can reduce by injecting power at that location. You reduce it and it's supply in the local area, therefore reduce the loading at that particular lines. Okay, right. So yes, come to the end. Okay, so I can conclude that PHEV can be used. You can utilize the PHEV to do the electric mobility. Okay, so no longer depend on the infrastructure. So you can use the in the future, you can use the PHEV to transfer the energy. For nowadays, we talk about, for example, we have you order online, food online, and the food come to your house, right? So 20 years or 30 years back, we don't even think about it. Okay, now you click on the screen and then food come to your home, right? With all this fleet on in Malaysia, we have food grab. Okay, so they deliver food to you. Okay, similarly in this case, so you can use PHEV to deliver, to transfer the electricity, so you don't really depend on the existing infrastructure. So basically, you can maintain the current infrastructure, utilize the available PHEV in the market, okay, and provide ancillary service. Utility company get benefit. The owner of the PHEV also get benefit. So when come to change the battery, so you can change free, okay, no cost, because it's already covered from the process of incentive and flexible tariff that you introduced just now. And as you can see, we can reduce the power losses, loading, and improve hosting capacity of renewable energy. So as you can see, loading before above 100%. If we use this PHEV, can reduce the loading. That's allow you to have more renewable energy. Okay. The worst case scenario only happen 1 hour, 2 hour only. Okay. The rest is not really operate at that worst case scenario. So why we need to invest on the infrastructure where we can use the available PHEV. So PHEV coming to the market very soon. Okay, more electric vehicle on the road. So yeah, I believe if we introduce this kind of what we call scheme or program, so we have some benefit from power grid point of view and also the PHEV owner. Okay, with that, I end my presentation. Thank you very much for listening. Maybe we can open to the Q&A session. Okay. I just prepared this slide for 1 hour, so 60 minutes, because I thought that we have another 30 minutes for Q&A session. Okay. Right. Thank you. So maybe just go back to the first slide.
Thank you, sir.
Right. Yes. Any
questions?
Sir, can we get this material for our reference?
I think I shared with the organizer before. Yeah, sure. You can get it Yeah, from the organizer. I shared it with the organizer.
Yeah. And which books or which transactions are better to refer this optimal scheduling?
All right, which book? You talk about book. Okay, normally we can refer to the research paper instead of book. Okay, but if you want to go for a book, because optimal scheduling here contains a few things. One is optimization, another one is electric vehicle. So and another one is power grid. So many components here. If you to go to books, you need at least 3 books here. One is talking about optimization techniques. Another book's talking about electric vehicle. Another book will talk about power grid. Okay. I would suggest you, if you want to go for the book, maybe you can go to electric. I forgot the name. Maybe I share later. Is that okay? I share in the chat box. Is that okay? I will find which
Sure.
book.
Okay. Okay.
All right. Okay. Thank you.
Participants, if you have any doubt, you can ask the resource person and get clarified.
Please provide the outcomes for third and
Sorry, I don't get it. Is that question or?
So good evening, sir.
Yes. Yeah. Good evening.
Can you give some more application related to this topic, PHV?
Application.
Yeah.
What do you mean by application in this case?
That is a real-time application I'm asking.
All right. Real-time application
Related to the IoT also, okay.
related to IoT. Okay. I don't really get your question. Basically, what kind of real time is that? Do you mean the lab test study or what? When you mentioned about
Uses of the appliances, I'm asking.
uses
It
of
is used for
appliance.
only for the electrical vehicles or some other things I'm asking related to IoT also.
All right. Okay. I tried to answer it, but I'm not sure whether I understand your question correctly. So when you say about appliances, I believe this more towards demand side management, where you can use IoT to know which appliances that you use at the moment. Okay. For example, at difference of time of, for example, you have flexible tariff just now, and you can check through your phone. For example, you have using the washing machine at house. When you talk about appliance, I'm not sure whether it's correct, but I try to understand.
Yes, sir. It's correct one, correct one. I'm
Okay.
watching this one. Yes.
All right, I see.
Thank you.
Okay. So basically, you can shift the time of use. We call it TOU, right? So you can shift your time of use depending on the price condition. For example, washing machine, you can program it where to use and where to not use. Okay. During high price, definitely you stop using the washing machine, and maybe during the low price you go to office and then you go to work, then you can control from your phone, because we talk about smartphone, smart house right now. So then you can operate your washing machine, do the laundry during that period, lower price period, so that you can save the your electricity bill. Okay, you can reduce your electricity bill. Okay, I think that's happened in UK where they have this kind of flexible tariff. Okay, people start do the demand shifting. Okay, from the peak hour into the off peak hour. I hope I answered your question. I'm not sure whether that's correct question or not. Okay.
Yes, sir, yes, sir, it's correct,
All
but
right.
your presentation is a splendid one. Thank you very much for this.
All right. Thank you.
Good evening, sir.
Yes. Good evening.
Sir, actually, in optimization related problem, uh, can you give more insight in the mathematical part? I mean,
Right.
objective function modeling, I mean, writing of objective function and constraints and everything.
I
Is
see.
it possible?
Yes, sure, sure. But the thing is, I don't have it in this slide, and yeah. All right. In this particular problem, our objective function is try to reduce power losses in the network. So I'm not sure how your background about what we call the optimal power flow. Okay, so this objective function basically try to reduce the power losses in the network. Okay, so the objective is minimize the power losses. Okay, that's minimize. How I calculate that? Basically, I calculate the power injection at one point and calculate the delivering power at the other point and sum all the losses in the network and get that power losses. That the objective, minimize the power losses. Okay. The constraint here, the constraint is limited to the number of charger. Okay, number of charger, and the constraint other than that only that because we do the maximum number, the boundary, okay, from 1 to 20, 0 to 20 for the charging, and location we limit the constraint from bus 1 until bus 33. That's constraint. That's general. I can say in general, okay. And if you want to go in detail how this optimization work, I don't have in this slide, but I have in another slide where you have all the process flow there. I don't think that's interest in this discussion, but anyway, you can contact me to get further. I can share you code as well if you want. Yeah, definitely I can share with you. So maybe I leave to you my email later on. Okay, so we can share the code if you want. Okay, definitely. Okay, then from there you can see in detail how the objective function and how the algorithm works. Okay, is it okay?
Thank you, sir. Thank you.
Okay.
I will try to contact you, sir.
All right. Thank you.
Thank you, sir.
Yes.
Hello.
Hello. Yes.
Good evening.
Good evening.
For optimization problem, which software is preferable?
Right. Software. I'm using MATLAB. Okay, MATLAB. And to calculate the power losses just now, power flow calculation in the MATLAB, we have power, map power, okay, map power inside, so that you can calculate the power flow. Okay, so you can use map power platform as a software that uses MATLAB environment. Okay, so my answer to that, using the map power that uses MATLAB environment. Okay, does that answer your question?
Okay. My question is softwares like MATLAB.
Yeah, MATLAB. Yeah, MATLAB. So if you talk about MATLAB, it's very general, right? MATLAB. I use MATLAB for this. Okay, MATLAB. Then you have tools. So many tools inside MATLAB, right? So to do this power flow calculation, we can use map power there inside. We kind of external coding for MATLAB. We call it map power. Are you familiar with that map power?
It's problematic.
Sorry, say again. I don't get your. Is it okay? Do you get my answer just now? Basically, it's MATLAB software. If you go to general, basically it's MATLAB software.
Okay, sir.
All right.
Thank you.
So basically, MATLAB, you can code all this optimization technique inside, and people share this optimization technique in the what we call the MATLAB platform. Okay, so you can get all these algorithms there, the optimization techniques, the heuristic optimization techniques.
Sir, one more doubt, sir.
Yes.
For optimization techniques is only suitable for particular problems, or it can suitable for any type of problems?
Right. It can solve any type of optimization problems. How we test this heuristic optimization technique? We test on the benchmark. We have many functions that try to represent the real life problems. So we have so many benchmark. So normally, those people who introduce this optimization technique will try on this benchmark function. Okay, you can see in certain benchmark perform better, in other benchmark function it's not perform better. Okay, is the therefore for example, gravitational search algorithm may be good in certain problem, but not in the at certain problem. Okay, so you have so many different problem in the world, so with different characteristic, with different behavior. So optimization is cannot cater everything, not able to cater everything. Some optimization good in this problem, but the other case, other problem, maybe the other optimization is good. Therefore, that's why we test all this optimization available, the latest optimization technique, and see which one is the best to use in solving this optimal scheduling. Otherwise, for example, maybe you can try with the gravitational search algorithm and you get solution. Definitely can solve the problem, but it's not perform. Maybe the other optimization more suitable for this. Okay, so my answer is that this optimization can basically solve all the optimization problem, but may not be the best option. Okay, so if you don't know what to do, and you only know one technique, then you apply it, then you get solution. Okay, it's better than not to try at all. For example, if you compare, basically we try this gravitational search algorithm. from the result, you can see that this technique is the, how can I say, the worst one. Okay, but if you compare to the numerical method like inter-point method, okay, this GSA perform better than that. Okay, so why this perform better? Because the heuristic method have this characteristic to escape from the local minima. That's why you get better solution. So yeah, that's my answer. So basically, if you use heuristic method, you can solve the optimization technique, optimization problem, but may not be the best one. So you can try with other technique that may give you more suitable to your problem. Okay, does that answer your question?
Thank you, sir. Thank you so much.
Thank you. Right.
Thank you, participants.
Thank you, sir. Thank you so much.
Thank you, ma'am. Thank you so much.
Okay, thank you.
For your wonderful involvement in this sessions and interact with our resource persons and clarify your doubts then and there. I hope the participants gained the valuable insights in terms of charging strategies, optimization goals, scheduling approaches, optimization methodologies, challenges, and trends. From this lecture, we realized that efficient scheduling is crucial for sustainable EV adoption and grid reliability. We extend our sincere thanks to our distinguished guest speaker for sharing their valuable insights. A special appreciation to our dedicated HOD, faculty members, and organizing committee for making this day a successful one. We also thank all the participants for their active participation and involvement to fulfill their thirst of knowledge hunger. We look forward to the insightful journey ahead in this FTB. Thank you all. Thank you, sir, for your
Okay,
wonderful
thank you very
time.
much. Okay, thank you.
Thank you, sir.
Bye.
Thank you, ma'am.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.